Thank you, and thank you very much for inviting me. This looks like a fantastic location, beautiful. I know Lisbon very well because I have collaborators there, so them frequently. I've now discovered the Algarve, and I find this is a location that's highly conducive to creativity. And from what I see, the contents of the sessions that were just presented, I'm very hopeful that this will bring new things coming out of this conference. So I'm going to talk to you about our take on neurotechnology, or how we're trying to break into the brain. Basically, my personal take on neurotechnology is it's a combination of doing neuroscience research and applying engineering principles to either study how the brain works, so that's the engineering design principles of the brain, or to understand from how the brain works, how to build technology that can end up helping the brain when it is diseased. So having spoken about so much the brain, maybe we should ask ourselves a very fundamental question. Why do we have brains? So if you look here at organisms that are living on our planet, you see this group here, plants, corals, fungi, all don't have brains. And all these organisms over here, fly, mouse, human, and so forth, they all do have brains. Now, it's my very personal take and that of some of my colleagues that all these animals have brain for one reason and for one reason only. Namely, they all move, and all these organisms here don't move. Suggesting that maybe the only reason why the brain was evolved is to control, predict, and generate future movement, be it for communication or manipulation of objects. Now, looking at control of movement, and I'm sure I'm preaching here to the converted already, is the challenge in understanding how difficult it is, because very often movement is taken as something very natural. So if you look at this PhD at Carnegie Mellon University, completed 2 years ago, so students spent 4 years of his life teaching this industrial robot to stack cups. That works all very fine, it's precision engineering, unless the cups are not perfectly stacked in the initial outset and the robot fails. And here's a comparison, oops, that shouldn't happen. We have a young gentleman, 7 years of age, and his take on cup stacking. And here he thought that he started too early, so he's restarting it and doing it faster than the whole robot did it in the first time. And I think this just beautifully illustrates how powerful our brain is in controlling movements. So in many ways, computers have outperformed humans. So Garry Kasparov was the last world champion in chess to then forfeit to a big deep thought machine built by IBM. And so clearly here we have lost out against the